Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 5 in the File Upload Vulnerabilities module titled Web Shell Upload via Obfuscated File Extension. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on file upload vulnerabilities, and select lab number 5 titled Web Shell Upload via Obfuscated File Extension. Alright, let's get started. This lab contains a vulnerable image upload function. Certain file extensions are blacklisted, but this defense can be bypassed using a classic obfuscation technique. To solve the lab, upload a basic PHP web shell, then use it to exfiltrate the contents of the file /home/carlos/secret. Submit the secret using the button provided in the lab banner. You can log into your own account using the following credentials, and we're giving credentials to a regular user account. Okay, so the target goal over here, if we click on View and Word Wrap, the target goal is to exploit the file upload vulnerability and bypass the defense that they have in order to upload a PHP web shell and then exfiltrate the contents of the secret file. All right, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. Okay, the first thing we're going to do is click on my account and log in with the credentials that we were given. So the password was Peter, hit login. It's the same application that we faced in previous labs. It gives you the ability to update an email address, but it also gives you the ability to upload an avatar. Now, whenever you have the ability to upload a file, you should definitely test it for file upload vulnerabilities. So what we're going to do over here is create a PHP script. So let's click on New File, call it test.php. Create the file, and then add the ability to run arbitrary system commands in our PHP script. So that's essentially what a web shell is. So we'll say system cmd, and here we go. All right, so essentially over here, we're saying take the cmd parameter from the GET request and execute it as a system command. So this cmd parameter can be any command that you want, and we'll run several commands once we get it to execute. All right, let's try and upload this file to see if it accepts it. Hit select and upload. And over here it says, sorry, only JPEG and PNG image files are allowed. Okay, so it definitely has some kind of defense mechanism in the backend that is preventing us from uploading our files. So let's send this request to Repeater and see if the defense mechanism has certain flaws in it. So when we send over here, we get the same error that we got in the browser, which is a 403 forbidden. And it tells us that only JPEG and PNG files are allowed. So my guess over here is it's looking at the file name, and if it doesn't have JPEG or PNG in it, it won't allow it to upload. So what we're going to do is we're going to add the PNG extension, and we're going to use something in PHP called a null byte. So that's %00. And what that essentially does is it tells the server to ignore everything after the null byte. So what will happen over here is when the application receives this request, it'll see it's a PNG image. However, the null byte, what it's going to do is tell the server to ignore everything after the null byte, and so we end up with our test.php script. So let's hit send over here and see if it accepted it. It says the file avatars test.php has been uploaded, so that's already a good sign. If we go back to my account over here and we right click, and it doesn't look like it's allowing us to load the image. Okay, so what we're going to do is we're going to right click and inspect over here and see where the image was supposed to be loaded. So you could see over here the file path to the image is /file/avatar/test.php and then the null byte. So let's copy the link address and then just go perform a regular request in the application, go to proxy. This is a regular GET request. Let's send this to repeater over here. And instead of visiting this path over here, we're going to visit the path to our web shell, which is this right over here. Hit send. It says not found, and the reason is because when the server processes this, it'll ignore everything after the PNG, and so it should be just test.php. Hit send, and we still get not found, so that's interesting. Let's try and visit the file right away in the browser. Okay, definitely does not work. Let's remove it. Put it in here and remove the %sign. Hit send. And here we go. So the file does exist. There must have been something wrong over here that it's not finding it. So something that I did incorrectly in the request. So if we go to proxy over here, this is the request and it's at 200 OK. So let's send this to repeater and remove this one over here. So if we hit send over here, it's a 200 OK. And then if we add our CMD parameter, the value of the CMD parameter will allow us to run any command that we want. So let's say the whoami command, hit send, and we got Carlos. So the server is running with Carlos privileges. If we say, let's say the hostname command, hit send, that's the host name of the server. Now let's output the content of the secret file. So cat +, which is the URL encoded version of space. And then let's say home, Carlos, and secret, hit send. And here we go. So we get the content of the secret file. Let's copy it, go back to our application, click on submit solution, okay. And we get the congratulations, you solved the lab message. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. So the request that we performed over here is first uploading the web shell. And then we also executed the web shell. But before we did any of that, we needed an authenticated session in the application. And so we logged into the application. Let's look for that request. It's this one right over here. Let's send that to repeater. Put it in order. So this is login. Now our script will need to perform all 3 requests in order to exploit the vulnerability. Okay, so as usual, we start off with importing all the libraries that we need. So the requests library, the sys library, the URL lib3 library, from BS4, import beautiful soup. We'll also import the random and string libraries, and from requests toolbelt, import multi-part encoder. All right, that's all the libraries that we need. Next, we're going to disable insecure request warnings. So disable warnings, URL lib3 dot exceptions dot insecure request warning. And then we'll set our proxy settings so that all of our requests get sent to burp. So all of HTTP traffic should be sent to HTTP 127.0.0.1, port 8080, that's where burp is running. Same goes for all HTTPS traffic. It should be sent to HTTP 127.0.0.1, port 8080. All right, next we'll define our main method. So if name is equal to main, then call the main method, and we'll define it right over here. So def main, if the length of the command line arguments is not equal to 2, so if the user ran the program incorrectly, then we'll print the usage instructions and the example instructions. So we'll start off with the usage. That's the name of the program and the URL. And the name of the program we take from the command line argument. We'll also print the example instructions, which is the name of the program and a sample URL. So let's say www.example.com, and the name of the program we take from the command line argument. And then we exit the program because the user ran it incorrectly. All right, let's assume the user did run it correctly. We'll first initiate our sessions object. So requests.session, and then we'll create a URL variable, and we'll take that from the second command line argument. So argv1, and then we'll call a function called exploit file upload that takes in the session object and the URL. Now this function is a custom function that we'll define right over here. This function will be responsible for performing all three requests right over here. So the login request, the uploading the web shell, and then the executing. So let's correct that. Executing the web shell request. All right, it takes in the session object and the URL. Now we'll start off with the login request. If we look over here, it's a post request to the /login endpoint. It takes in three parameters: the CSRF parameter, the username parameter, and the password parameter. Now, just like with previous labs, the CSRF parameter is a token that is taken from the previous request, which is listed in the referrer header. So it's to the /login endpoint. So if we go to proxy right over here and look at that endpoint, you'll see the CSRF parameter is in the response of the request. It's in an input element that has a name attribute that is equal to CSRF, and it has this value right over here. And so we first need to extract it from this request before we can log in. So we'll add a comment saying get CSRF token, and we'll need the login URL for that, which is the URL plus the /login endpoint, and then CSRF token itself would be equal to get CSRF token, which takes in the session object and the login URL. Okay, so in order to get the CSRF token, we need to implement logic that performs this request and then parses the response to obtain the CSRF token. We could implement the logic right over here in this function. However, we'll need to use that logic again in order to obtain the CSRF token for uploading a web shell. And so instead of rewriting it, what we'll do is we'll just write a new function called getCSRFToken that is solely responsible for obtaining the CSRF token, and this way we could use it again and again. So getCSRFToken, session, and URL. This one's really simple. It's just a get request to the URL that is passed to the function. So URL, we set verify to be equal to false because we don't want to verify TLS certificates, and proxies to be equal to proxies because we want the request to be sent to burp. And then we'll use the beautiful soup library to parse the response, and we'll use html.parser to parse the response. And so the CSRF token, the way we're going to extract it is we're going to say soup.find. And if we go back to proxy over here, we're going to say look for the input element that has the name CSRF, and we want the content of the value attribute. So we'll start off by saying look for the input element that has the name attribute, and the name attribute has to be equal to CSRF. And then we want the content of the value attribute, and then we return the CSRF token. Now when it's returned, it gets saved in a variable called CSRF token, and now we have everything that we need to log into the application. So let's add a comment saying log in as the user that we were given. We'll also print a statement saying logging in as the user that we were given, and then we'll define the rest of the parameters. So data login, this takes in three form parameters. The first one is the CSRF token. So CSRF, that's equal to CSRF token, which we just extracted. The next one is the username, which is equal to the username that we were given. And then password is equal to the password that we were given, which was Peter. All right, now we have everything that we need to log in. So R is equal to s.post because it is a post request. It takes in the login URL. Data is equal to data login. We set verified to be equal to false because we don't want to verify TLS certificates, and proxies to be equal to proxies because we want our request to be sent to burp. Now we need a way to confirm that we successfully logged in. So we're going to look for a logout string in the response of the request. And if we find it, that means we've successfully logged in as the user. But if we don't find it in the response, that means we were unsuccessful in logging in. So could not log in, and we'll exit the program because this is an authenticated vulnerability. And so you need to be authenticated in order to exploit the vulnerability. All right, let's assume that we logged in. Next, we need to perform the request that uploads the web shell. That would be this request right over here. Now, if we look at the request, it's to the /myaccount/avatar endpoint. It takes in the avatar parameter. It also takes in the user parameter and the CSRF parameter. Again, the CSRF parameter is something that extracted from the previous request, which is, if we look at the referrer header, it's the /myaccount request. And so we first need to extract it, and then we could perform our request to upload a web shell. So we'll first print uploading web shell, and then we've got the my account URL. That's equal to the URL of the main application plus the /my account endpoint. And then we obtain the CSRF token. So we'll say CSRF token is equal to get CSRF token. We give it the my account URL because that's where it needs to extract it from. And it also takes in the session object. All right, so we're just using the function that we implemented in order to obtain the CSRF token. And then we're going to create another variable called avatar URL. That's equal to URL plus the URL to upload an avatar, which is this one right over here. So let's copy that. And then we just define the parameters in the request. So we'll call that params. And the first one over here is the avatar parameter. So let's copy that. That takes in a file that has the name test.php and the value, which is our PHP web shell right over here. And we need to put that in double quotes because we already have single quotes in our exploit. And then it takes in the content type, which is this right over here. All right, that's the first parameter. The second parameter is the user parameter, which is just the username of our user. And then the third parameter is CSRF, which is equal to CSRF token, which we just extracted. All right, now if we perform the request, it'll perform it using form parameters, which looks like this, but that's not how it's performed in this request over here. Instead, we need to use a multi-part encoder in order to perform it. And so it needs to have this string right over here, plus a random alphabet and digit string. So this part over here is a random string of 16 digits and alphabets. It doesn't matter what string it is as long as it's the same for each parameter. And so we need to generate that ourselves. So we'll say boundary is equal to this string right over here. Let's copy that, put it in here, and then we'll add to it the random 16 digits and alphabets. So we'll say dot join, random dot sample, and I need a random sample of ASCII letters plus digits. And I only need 16 characters of those. All right, this looks good. And then we'll say M is equal to multi-part encoder, fields is equal to params, and boundary is equal to boundary. This simply puts it in this format right over here. And then we could just perform the request. So we'll say headers is equal to content type is m.content type. And then we perform the request. So as.post, it takes in the avatar URL. Data is equal to m. Headers is equal to headers. Verify is equal to false because we don't want to verify TLS certificates. And proxies is equal to proxies because we want our request to be sent to Bert. All right, so this performs this request right over here. Now what's left is to perform the GET request, which executes our script. So let's say execute script or PHP web shell. Let's take in the URL. So cmd URL is equal to this URL right over here. Let's copy it. It's the URL of the main application plus this. And you don't need to URL encode it. The script will URL encode it for you. And then we just perform the GET request. So R is equal to s.get, cmd URL. We set verify to be equal to false and proxies to be equal to proxies. And then we simply print the response of the request, which gives us our secret string over here. So it might be worthwhile to print over here the following is the content of the secret file. All right, this looks good. Hopefully there's no errors. Usually when I write a script, I test each and every component. I don't write the entire thing and then test it all at once, but let's hope that this time there's no errors. So go to terminal, new terminal, and while that loads, let's open a new instance of the application because it timed out. And then we'll say Python 3 file upload lab05.py, and we'll copy the URL to the application. Let's paste it in here, remove the trailing slash, hit enter, and so far so good, no errors. And here we go. So it outputs the content of the secret file, and it performs all three requests for us in an automated fashion. So if we hit OK, we get the congratulations, you solved the lab message. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at another case of a file upload vulnerability.